Today, we're diving into a whole new way of thinking, a way of seeing the world that's totally changing how we tackle our biggest problems, from the economy to our own brains. It's a science that asks us to look at everything a little differently, and it all starts with a really big question.
So, let's just start there. Have you ever wondered why the really huge challenges we face, like climate change or financial crises or even understanding consciousness, feels so incredibly stubborn? It's because they're not simple problems. You can't just find one broken part and fix it. They're what scientists call complex systems, and to even begin to understand them, we have to let go of our old way of thinking.
For, centuries, the name of the game in science was reductionism. The idea was simple. If you want to understand something big, you break it down into its smallest parts. To understand a car, you study the engine, the wheels, the electronics. Makes sense, right? But this new way of thinking, complexity science, says, hold on a second. For a lot of things, the most important stuff isn't in the parts, it's in the way they all connect and interact. The whole isn't just bigger than the sum of its parts, it's a completely different beast.
So what exactly is a complex system? Well, it's pretty much any system where a whole bunch of different things are interacting. Think about a city, a rainforest, the stock market. The key here is that we're not just studying one person, or one tree, or one stock. We're looking at the weird, unpredictable, and amazing behaviors that emerge from all those connections. The traffic jams, the sudden market crashes, all those patterns that none of the individual parts planned.
Okay, so to make sense of all these crazy interactions, we're going to need a new toolkit. And our first tool is something you've probably heard of, but it might not be what you think it is. I'm talking about the mathematics of strategy, also known as game theory.
Now, forget about board games or video games. At its heart, game theory is the science of strategy. It's a way of using math to understand any situation where the result of your choice depends on what someone else chooses. It is, quite literally, the math of how we all influence each other.
And the classic hawk-dove game shows this perfectly. It's so simple. Imagine two players find some food. If they both act like peaceful doves, great, they share. If one plays an aggressive hawk and the other a dove, the hawk takes everything. But what if they're both hawks? Well, then they fight, get injured, and both end up worse off. This tiny model is amazing because it helps explain that constant tug of war between cooperation and conflict that you see everywhere.
And this is where it gets really wild. These ideas aren't just theoretical. The same math that describes the hawk-dove game helps us understand why animals evolve certain behaviors, how countries negotiate treaties, and why companies get into price wars. It's this incredible bridge connecting biology, economics, and politics all together.
So, game theory helps us figure out the rules of interaction. But what about the actual structure of all those interactions? Who is connected to whom? That brings us to our next amazing tool, network science.
Network science sounds fancy, but at its core, it's beautifully simple. You've got nodes. Those are the things, the dots. They could be people or computers or neurons in your brain. And then you have edges. Those are the lines connecting the dots. By just mapping out the dots and the lines, we can start to see the hidden architecture that holds our world together.
And believe me, once you start looking for networks, you see them absolutely everywhere. Your friends on social media? That's a network. The internet itself is a massive technological network. The food web in your backyard is a biological network. This whole perspective just flips a switch in your brain. You realize the world isn't just a pile of separate things. It's this incredible, tangled web of relationships.
All right, so if the world is packed with these complex, connected systems, where can we find the best instructions for how to build things that work? Well, let's turn to the planet's undisputed expert, which has been running tests for about 3.8 billion years, nature. This idea is called biomimicry. Sometimes the most profound discoveries start with a kind of funny question. For instance, what on earth could a colony of ants scurrying around for food possibly teach us about running a global shipping network?
The answer? A lot. It turns out, a whole heck of a lot. You have to think of nature as this giant living library of brilliant ideas. Every single organism, every ecosystem, is a design that has survived billions of years of ruthless testing and optimization. Nature has already solved problems that we're just now bumping into.
And just look at this. It's incredible. We're literally translating nature's genius into powerful computer code. The way ants forage for food inspired ant colony optimization, which helps solve routing problems for companies like FedEx. The process of evolution itself inspired genetic algorithms. And the way our brains are wired, that's the blueprint for the artificial neural networks that are powering the entire AI revolution. We're basically borrowing from nature's R&D department.
Okay, so we've looked at game theory, we've looked at network science, we've looked at biomimicry. Let's zoom back out now and see how all these incredible pieces snap together to form something truly revolutionary.
See, complexity science isn't really just one field. It's more like a new operating system for science itself. It's this universal framework that uses all those tools we talked about to uncover the fundamental rules that govern how systems, any system, from a single cell to an entire civilization, organize themselves, adapt, and evolve. It's the search for the laws of organization itself.
And this didn't just happen overnight. The seeds were really planted way back after World War II. But a huge moment was in 1984 when the Santa Fe Institute was founded, a place dedicated to nothing but studying these complex systems. And now, today, it's a massive field that's shaking things up everywhere.
And this is so key. To do this new kind of science, you needed a new kind of place to do it. The vision for the Santa Fe Institute was totally radical at the time, an institution without fiefdoms. The whole point was to tear down the walls between physics and biology and economics so the smartest people could just get in a room together and attack these problems from every angle.
So what's the big takeaway here? What should you remember? Well, first, our toughest challenges are system problems. We have to see the whole forest, not just the individual trees. Second, the magic is in the connections. The interactions are often way more important than the individual parts. Third, there are universal patterns out there, connecting everything from ant colonies to our own economies. And finally, and this is the hopeful part, understanding all this gives us a powerful new toolkit to build a much, much better future.
And all of this leaves us with one last mind-bending question. As we get better and better at using this new lens, what amazing things, what hidden patterns are we going to discover tomorrow simply by seeing the world not as a collection of things, but as a beautiful, intricate network of relationships?
Hey, if this explainer helped you see the world in a new light, do us a huge favor and hit that subscribe button. We've got so many more deep dives coming into the incredible science that is literally shaping our world. Thanks for hanging out with us.